So we'll do questions related to topic moles and acid from question 11 onward. First question 11 is there that which compound is having a same molecular and empirical formula. So how we can work out will have same empirical and molecular formula. You can also state the answer. What you think is the right, you can also state the answer. So C2H4 is there. That's a molecular. So when we take a simplest ratio, because 2 and 4 can be further simplified as CH2. So it cannot be A. When we check option B, because option B 3 and 8, so 3 and 8 cannot be further simplified. It is already in the simplest ratio in whole number. So this will have the same molecular and empirical formula. What about option C? Option C 2, 4 and 10 can be further simplified as 2 and 5. And same way 5 and 10 can be further simplified as 1 and 2. That's why B is the right answer. Moving on to the next question. There are 6 exponent 23 atoms in 0.25 moles of. So how we'll know, how we can work out this question, that the number of atoms in 0.25 moles of helium. So example, we know 1 mole of helium, 1 mole of anything will have 6.02 into 10 to the power 23 particles, because helium is atom like exists as a monoatomic gas. So if we have 0.25 moles, then it will be X. Cross multiply, so this will come out as 0.75 into 10 to the power 23 atoms. So it cannot be A, because 1 mole of any substance contains 6 exponent 23 particles. It can be atoms, molecule, depending on the type of the substance. So if we have 0.25 moles, then how many atoms will be there? It will have 0.75 into 10 to the power 23 atoms. So it cannot be helium. Then we check the second option. About the water, we know 1 mole of a water is having 6.02 into 10 to the power 23 molecule, because water molecule is there, so it is having molecules. So when we work out 0.25 moles of H2O, how many molecules will be there? 0.25 multiplied by 6 exponent 23. So it will be about 1.5 into 10 to the power 23 molecules. But we are in the question, they're asking for atoms. So how we'll work out? We know like one molecule contain how many atoms? One molecule of H2O contain 3 atoms, 2 hydrogen. So the ratio between molecule is to atom is 1:3. So if we have 1.5 into 10 to the power 23 molecules, then how many atoms will be there? X. Cross multiply, so this will be 3 times. So this will turn out to be 4.5 into 10 to the power 23 atoms. So that cannot have 6.02 into 10 to the power 23. So that's why B cannot be an answer as well. Then is it clear why B is not an answer? Because 1 mole of a water contains 6 exponent 23 molecule. So if we have 0.25 moles of water, it will have 1.5 into 10 to the power 23 molecules. And in the question, they are asking for number of atoms in. So the ratio of the molecule, like one water molecule contains 3 atoms, in which 2 of them are hydrogen and 1 of them is oxygen. So ratio is 3:4. 1 is to 3. So if we have 1.5 into 10 power 23 molecules of the water, then how many atoms will be there in it? It will have 4.5 into 10 power 23 atoms. So it cannot be B. What about option C? When we check option C, as we know, 1 mole of pH3 will have 6.02 into 10 power 23 molecule, because it is a molecule, so it will have molecules. So if we have 0.25 moles of BH3, then how many molecules will be there? X. When we solve for X, we'll get 1.5 into 10 power 23 molecules. Then we'll take a ratio, because one molecule of BH3 contains 4 atoms. 3 of them are hydrogen and 1 is boron. So one molecule of BH3 contain 4 atoms. So ratio between molecule is to atom is 1 is to 4. So if we have 1.5 into 10 power 23, then this will be x cross multiply. You will get about 6 exponent 23 atoms, and that is the question, that there are 6 exponent 23 atoms in 0.5 moles of BH3. So C is the right answer for this. Is it clear? Then question 13. Which aqueous solution contain the highest concentration in mole per dm³ for chloride ion? 0.1 gram per dm³ of HCl, 0.1 gram per dm³ of NaCl, 0.1 gram per dm³ of KCl, and 0.1 gram per dm³ of BaCl. So first what we will do, we will convert all the concentration into, because this is concentration in mole per dm³, we have to convert the concentration, so the concentration in gram per dm³, we have to convert all the concentration in mole per dm³. So basically we have to convert this gram into mole, and how we can convert the gram into mole? We have the formula moles equal mass in gram divided by molar mass. So for HCl it is 0.1 gram. So if it is 0.1 gram divided by molar mass, what is the molar mass of HCl? Hydrogen is 1 and chlorine is 35.5, so the total will be 36.5. So 0.1 divided by 36.5. What is the answer for this? 0.1 divided by 36.5. The concentration of HCl 0.0027. So this will give us the concentration of 0.0027. So, but this is a concentration of HCl. Then HCl, when it will dissociate into hydrogen ion and chloride ion. So ratio of HCl and chloride ion is 1 is to 1. So we'll have the same concentration. Yeah, 2.74 exponent minus 3, or it is same as 0.0027. So the ratio of HCl and chloride ion is 1 is to 1. So what will be the concentration of chloride ion? Because 1 is to 1 is the ratio. So it will have the same concentration, 0.0027. Then we check the concentration for sodium chloride in mole per dm³. So moles equal mass in gram over molar mass. Again the mass in gram is 0.1 divided by molar mass. Sodium is 23 and chlorine is 35.5. So it will be 58.5. So 0.1 divided by 58.5. What is the answer in mole per dm cube? And it will be less than the first value because we are dividing with a greater denominator. 0.0017. So it is 0.0017. And NaCl dissociate into Na plus and Cl minus. Again the ratio is 1 is to 1. So the concentration of the chloride ion will be 0.0017. Then we check for potassium chloride. Again it will be 0.1 divided by potassium is 39 and chlorine is 35.5. So 39 plus 35.5, and that answer will be there in denominator. So 0.1 divided by mass of potassium chloride. What will the concentration in mole per dm cube? 1.34 into 10 power minus 3, or 0.00134. And potassium chloride will dissociate into potassium ion and chloride ion. So we'll get the concentration as 0.00134. Then the third one is about barium chloride. So we'll get the concentration of a barium chloride. Mass is 0.1 divided by the molecular mass. Barium is 137, and 138 you can also take if there is an isotope. For example, that is 138 plus chlorine is 35.5 multiplied by 2. So what is the concentration of barium chloride in mole per dm cube? 0.1 divided by the molar mass of barium chloride, 138 plus 35.5 times 2. So it will be a very small concentration, 0.000478. So 0.000478, and then the ratio of barium chloride to barium chloride ion, that is 1 is to 2. So if it is 1 is to 2, if we have the concentration 0.000478, then this will be X. What will be the concentration of the chloride ion, the value of X? So 0.000478 times 2, multiplied by 2, 0.000478. We will get the concentration of the chloride ions. So it will be 9.56 into 10 power minus 4. Or we can also say, so 9.56 into 10 power minus 4, or we can also say it is 0.000956. And the question is, which solution contains the highest concentration? The first solution was 0.002, second was 0.0017, the third one is 0.0013. So which is having the highest? So 0.002, A will be the right answer. So we have to work out the concentration for each, and then we use a ratio to work out the concentration of a chloride ion, because the first three examples, the ratio of molecule is to ion, chloride ion is 1 is to 1. That's why we did not multiply with anything. We got the same concentration. But for this last one, because it contained two chloride ions, so ratio of molecule to chloride ion is 1 is to 2. That's why the concentration will be times. In question 14, a substance is labeled with a hazard symbol shown. So this symbol is shown. What is the meaning of this symbol? So it shows a substance is corrosive because when added to metal, a reaction occur. When it come in contact with the skin, a reaction can occur. So the substance is corrosive. That's why B is the right answer. In question 15, this question is about the production of squalane, a liquid squalane alkane which occur naturally in human skin and is used in cosmetics, suggests two properties that make squalane useful in cosmetic. So it's a general property. Like example, because it is used in cosmetics, so if something is used in cosmetic, it should not be reactive. It should be non-toxic or non-irritant, and it should be chemically inert or stable. Or it should be non-toxic. Give a molecular formula of squalane. So how we can work out the molecular formula of squalane? This is related to organic chemistry that we will discuss in the last topic. But here at the end, this is called a skeletal formula. Here at the end, it is CH3, CH3, CH, then CH2. This is CH2, CH2, CH, CH3, CH2, 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 C, CH3. This is CH, CH2, 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 CH, CH3, CH2, 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 CH, CH3, CH2, 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 CH, CH3, and then CH3. So we have to count the total number of carbon atoms and hydrogen. So it contains about 30 carbon atoms. And because you can see it is an alkane. If you remember in O levels, we discussed the general formula of alkane is CN H2N plus 2. So number of hydrogen will be twice as compared to number of twice plus 2 as compared to number of carbon. So double will be 60 and plus 2. So it will be 62. So general molecular formula will be C30 and H62. Then squalane can be produced from squalene, an alkene present in a shark liver oil, by reaction with hydrogen in the presence of suitable catalyst. Give a name of suitable catalyst for hydrogenation. So normally if we do hydrogenation or add hydrogen, so it is we use nickel as a catalyst. Then squalane used in cosmetic must contain no more than 0.2 parts per million by mass of catalyst. Calculate the maximum permitted mass of catalyst in production of 50 gram of squalane. So if we are producing a 50 gram of squalane, what should be the mass of the catalyst present in it? So we have the formula that concentration in ppm is mass of substance or mass of solute divided by total mass of substance into 1 million. That's a formula to get the concentration. So the permitted concentration is 0.2. So we have this as 0.2. Mass of a solute, mass of the catalyst we are finding, and mass of a substance is in 50 grams, then into 1 million. So we need the mass of catalyst, so 0.2 multiplied by 50 divided by 1 million. So if it is 0.2 multiplied by 50 divided by 1 million, what's the answer for the permitted mass of the catalyst? 0.2 into 50 divided by 1 million. So it will be 0.00001 gram. So that will be the permitted mass of the catalyst present in squalane. Yeah, 1 exponent minus 5, that's right as well. Is it clear, this part? Then a reactor at 200 degrees centigrade contain 8,500 moles of liquid squalene and hydrogen gas at a pressure of 4 exponent 5 Pascal. Under these conditions, complete hydrogenation of squalene requires 500 meter cube of hydrogen gas. Calculate the number of the double bonds in one molecule of squalene. Basically, what happened? Uh, if we can work out the number of moles of hydrogen, we can work out the number of double bond because one mole of hydrogen react with one double bond. So if we know the number of moles of hydrogen, we can work out the number of the double bonds present in this squalene. So we have the formula, even the formula is given that PV is equals to nRT. So we need the number of moles of hydrogen, so N is equals to PV divided by RT. What about the pressure? That is given 4 into 10 to the power 5 Pascal. The volume for hydrogen, that is 500 meter cube already, so we don't have to convert. But temperature is given in degree centigrade, so we have to convert into Kelvin. So what we do to convert into Kelvin, we add 273, so 200 plus 273, that will give us 473 Kelvin. R is a general gas constant, the value is already given. So we substitute these values. So when we substitute the value, the 4 into 10 to the power 5 multiplied by 500 divided by general gas constant 8.31 and then 473. So we'll get the number of moles of hydrogen, which is 50,882. Now we'll take a simplest ratio between hydrogen and squalene, because the ratio between them, as they mention in the question, that we have 8,500 moles of liquid squalene. So the ratio of squalene to hydrogen, we have 8,500 moles of squalene and we have 50,882 moles. So we'll divide it by smallest value 8,500. So this will be 1 and this will be 6. So it means 1 mole of squalene reacted with 6 moles of hydrogen. So if 6 moles of hydrogen are there, how many double bonds are present in this squalene? It contains 6 double bonds. Is it clear how we work out the number of double bonds in squalene? Look, in the last part, first what we did, we work out the total number of moles of hydrogen. So PV is equals to nRT is giving the moles of hydrogen. Then what we did, we know that 1 mole of hydrogen react with 1 double bond. But in the question, we don't have 1 mole of squalene. How many moles of squalene are given in the question? We have 8,500 moles of squalene are there. So what we did, we are taking a ratio between, like, because we are finding how many moles of hydrogen reacted with 1 mole of squalene. So we are taking a simplest ratio between a squalene and hydrogen. So the moles of squalene are 8,500 and moles of hydrogen which are present, that is 50,882. So we are taking a simplest ratio between them. So we divide by 8,500. So this will be 1 and this is coming out 6. So it means that 1 mole of squalene reacted with 6 moles of hydrogen. So ratio between, so how many double bonds are there in squalene? Because it is reacting with 6 moles of hydrogen. So it means there are 6 double bonds, because 1 mole of hydrogen react with 1 double bond. So 6 moles of hydrogen means 6 double bonds are there in squalene. Is it clear? Then write equation using a molecular formula, complete hydrogenation of squalene to squalane. Squalane, we already worked out, it was C30 and H62. And for 1 molecule of squalene, this is squalane, ANE. It was reacting with 6 moles of hydrogen. This is hydrogen. So how many moles of squalene will be there? 12 hydrogen. So this will be C30. 12 hydrogen are used here. So this should be 50. So C30 and H50 should be the molecular formula for squalene. Because C30H50 reacted with 12 hydrogen to form C30 and H62, which is squalane. The next part, globally, about 2.8 million dm cube of squalene is used each year. So every year we use 2.8 million dm cube of squalene. Traditionally, squalene was obtained exclusively from shark liver oil, which is a mixture of oil liquids. The liver of a shark yields 300 gram of squalene. So inside the liver, it's about 300 gram of squalene. Suggests the name of suitable technique to obtain squalene from shark liver, because we are separating different oils, different miscible liquids from each other. So a technique which we use to separate 2 or more miscible liquids, we call that as fractional distillation. Then calculate the minimum number of sharks that would be needed to produce 2.8 million dm cube of squalene. So how we can work out a liver of a shark? Like one shark can give about 300 gram of squalene. So first we'll find the mass, the total mass which we need. So density is equals to mass divided by volume. The density of the squalene is 0.86. The mass which we need to produce this 2.8 million dm cube, so it will be, but you can see the density is given in gram per cm cube and the volume is given in 2.8 million dm cube. So what we have to do, first we have to convert this volume into cm cube because the density is in cm cube. So to convert the volume from dm cube to cm cube, and it is 2.8 million. So 2.8 million dm cube to cm cube. Yeah, we'll multiply by 1000. So 2.8 million dm cube. So 2.8 million means 2.8 into 10 to the power 6. And to convert the dm cube into cm cube, we have to multiply by 1000. So this will be multiplied by 1000 or 10 to the power 3. So what we'll get 2.8 into 10 to the power 9 cm cube. So that's a volume of squalene, and we have the formula, density is mass over volume. So density of the squalene is 0.86. Mass of squalene we don't know, the total mass which we need, and the total volume of squalene which we need is 2.8 into 10 to the power 9 cm cube. So that is multiplied by 0.86. So it will give us 2.4 into 10 to the power 9 gram. And so total mass of a squalene which is needed is 2.4 into 10 to the power 9. And one shark can provide 300 gram. So if I divide by 300 gram, like when we take a ratio for shark and the mass of a squalene which is provided, one shark can provide 300 gram. But if we need 2.4 into 10 to the power 9 grams, how many sharks we need? X, cross multiply. So the total number of sharks required to produce this will come out as 8 into 10 to the power 6. 2.4 into 10 to the power 9 divided by 300. So this will give us approximately 8 exponent 6 sharks are needed to produce this much mass of squalene. Is it clear? Discussion? Because one shark can yield 300 gram of squalene. So which is a very big number, like 8 billion sharks are needed to produce this much mass of squalene. Then many large corporations now use squalene obtained from plants. Squalene can be obtained from corn starch, which give 23% by mass. A production of 1 ton of corn starch required a 0.093 hectares of land. This is the size of land needed. Calculate the area of land in kilometer square. Produce 2,500 tons of squalene from a corn starch. So First, we will find how much cornstarch is there needed. If we want to produce 2500 tons and it is 23% yield, so what is the mass of the cornstarch needed? So that will 2500 tons divided by 23 into 100. This will give us the total mass of a cornstarch which is needed. So it is about 10,869 tons. Because I mentioned by mass it is only giving 23%. Like if we need 2500 tons, so 23% by mass is producing, the cornstarch is producing squalane. So this is the total mass in tons which we need a cornstarch. Then the total land which we need. So 10,869 tons. As you can see here, they mention to produce 1 ton we need this hectares of land. So if 10,000 is there, 10,869 multiplied by 0.093 will get the total land in hectares. So this will come out as 1010 hectares. And now we have to convert the hectares into kilometers square. As I mentioned here, that 1 hectare is equals to 0.001 kilometer square. So 1 is hectare to kilometer square 0.01. So if we have 10,010 hectares, we'll have x kilometer square. So this will be x. About we need 10.1 kilometer square of land to produce this much starch. Is it clear, this question? So first what we did, because I mentioned we want to produce 2500 tons of squalane from cornstarch and that can only produce 23%. So we are finding first the total mass of a cornstarch needed, which is 10,869 tons. And to grow this 10,869 ton, because for 1 ton we need this much space. So 10,089 we need 0.09. So we need 1,000 hectares and ratio of hectares to kilometer square is 0.01. So 10,010 hectares, we need x kilometer square. So we need about 10 kilometers square land to produce this cornstarch.